Hello, children. I am coming to you live from my living room in front of a fire. I'm feeling pretty lousy. Got the dog by my side, who's really not helping. But did not want you to miss out on a day of learning, so here we are. The windshield problem. What do you do when a raccoon jumps onto your windshield when you are driving? That's actually not the windshield problem, but I could not resist the picture. Okay, so in all seriousness. So let's say that you have a windshield cleared by a single wiper blade, just like in the picture here. The reach of the wiper is 40 centimeters, so there's the reach, while the blade itself is only 30 centimeters. If the arm rotates 140 degrees each swipe, what is the area cleaned by the blade, and does the top of the blade cover the same distance as the bottom of the blade? So you can sort of instinctively, think about the answers to those questions. I guess the area question is not going to be so much of an instinct. It's probably going to require a little bit of calculating, and then you may have an instinct about whether the top travels the same distance as the bottom, or they sort of parallel and same distance. Yeah. Anyway, so give that some thought. You can pause the video a little bit, and just give it some thought. Like, how would you approach solving that problem? So in case you had a difficult time picturing what it would look like, you get sort of this, I don't know what you would call that shape, but you get this sort of, this thing is going to draw here. You get this sort of shape like that, okay? As the wiper goes, and it's only going 140 degrees. That might be a 140-degree angle. You have to try to figure, okay, how would I figure out that area, and how would I figure out, like, that length and that length? So we're going to start with something a little more basic. We're going to begin with just how to find arc length. This may be something that you learned in geometry, so this might be review. And if it's review for you, then you can just, flip through this video really quickly. There are formulas for finding these things, and I loathe formulas, because if you don't remember the formula, or you don't remember the formula correctly, excuse me, then you're in trouble. So I think that these are very logical to just think about as what percent of the circumference have you traveled? Okay? It's simply a percentage of the whole. And the whole, compared to arc length, is our circumference. And the percentage of the whole can be found by dividing the central angle. Central angle is one that's formed with the center of the circle as the vertex and radii as the sides of the angle, and this is called an intercepted arc. This is the central angle reaches out and grabs the side of the circle, and that's called an intercepted arc. Again, you may remember this from geometry. So we could figure out the percentage of the arc just by figuring out the percentage, or the percentage of the circle we've traversed. How many out of 360 degrees, or how many out of 2 pi have we gone? Excuse me. Finding the area of a sector is exactly the same thing, but instead of comparing the percentage of the circle to the circumference, you compare the percentage of the circle to the area, because a sector is like a piece of pie. So it's an area as opposed to just a length along the side. Okay, it's got 2 dimensions. Okay, so you find the area of the circle. You know how to do that. And then you figure out the central angle that intercepts that sector. And then you take that percentage of the area. It's really very intuitive, very logical. So here are some examples for finding arc length. We'll do one together, and then you can do the rest. Okay, so we're looking for this big arc length here, because they've shown us this angle there. Okay, And it says do not round, and that's what I would like you to do. I don't want you to round. So the circumference of the circle is 32 pi. I hope I don't have to explain that. In fact, I explained it during assembly last year. The ratio of the circle we're talking about, or to find the percentage of the circle we're talking about, we could say, what is 240 over 360? Okay? Well, I like to do this kind of thing. So 12 goes as 2/3, right? So we're talking about 2/3 of our circle here. So we can either, we could find a percentage here. In this case, we would have to round it. So I'm liking the fractions. So 2/3 of 32 pi. We end up with 64 pi over 3. And let's just leave it like that. Okay? Much easier than multiplying the pi through and dividing and getting something icky. So what I'd like you guys to do is you can pause the video and you can try doing 18, 19, and 20 at your pace. And then, as you can see, we'll go on to the next page. And the answers are here. So obviously, don't unveil until, don't stop the video until you're ready. Sorry, we experienced a little technical difficulty. Mostly my brain. Okay, so notice these examples are similar. They may actually be even the same. But we're talking about area of the sector now. We're talking about that area there. Okay? So, in this case, instead of finding the circumference, we're going to find the area of the circle. And we know that we square the radius and then multiply it by pi. So 16 squared, I think, is 256. No, it's 296, right? What is it, Hanji? 13 is 169. 14 is 196. Oh, I think it is 60. Help me, Hanji. $15 is 225, so I think it's maybe 256. Yeah, it's 256. I'm so good at this. Okay, and we decided that 240 of 360 was 2/3, so we do 2/3 times, 256 pi over 1. I know that 256 does not have any factors of 3 because it comes from 16, and 16 is 2, and 2, 2, and 2. So my final answer is just going to be 512 pi over 3. That might bother you, but I like it. It's clean. There are no decimals. We got the pi there. It's beautiful. Okay? So let's do the same thing here. You can find the area, you can practice finding the area of these sectors. And we'll go on to the next page. You can pause the video, obviously. And then pause the video, and then I'm going to reveal the answers. And there they are. Okay? So obviously, if you're not getting these right, you might want to go back and watch the video again. Try them again. So lastly, the last thing I want to do is ask you to go back to the windshield problem and see if maybe now you can figure it out, given all of this information. Now, it's problem solving. You're going to have to do maybe a couple of steps. But maybe if you find a classmate who is finished watching this video at the same time you are, you can get together and see if you can figure out the answer to the windshield problem. Stay tuned. I don't have an answer to this particular problem yet, but I will provide it on Saturday, either in person or in the form of Jetson style, in the form of a video. So here is your homework. This homework is not nearly as straightforward as the examples. Those examples are very basic, and these are more problem-solving type problems. Maybe one or two of them are basic. I honestly can't remember at this point. So get that down and enjoy, do your best, and stay healthy, and I'm hoping to see you on Saturday.